Hey again, Dr. Mashburn. So today we're going to cover our blood vessels. All right. So blood vessels are the tubes that we carry our blood throughout our body. Okay. And blood vessels come as arteries and capillaries and veins. And so it's a dynamic structure. It's a continuous loop that begins and ends at the heart. Okay. So you have your heart. Blood's going to come into the heart. It's going to go through the heart. It's going to go out to the lungs. It's going to go back out the heart to the body and then back in. Okay, so it's just one continuous loop. And at some point in the semester, I'm going to teach you how to trace a single drop of blood throughout the entire body. Okay, so that's coming. It sounds scary, but actually it's kind of like a puzzle, and most students find it to be fun. These blood vessels is a delivery system for blood, and the arteries carry blood away from the heart. Okay, so A and away. The capillaries are the small vessels that are between the arteries and the veins. So you have arteries, and then capillaries, and then veins. And capillaries is where exchange occurs. So you can have capillaries in the lungs where oxygen will enter the capillaries and carbon dioxide would be removed, and capillaries in the body where you would take the oxygen from the blood to the body and the carbon dioxide from the body to the blood. Okay, that's the capillaries. They're the exchange places. And then the veins carry the blood back to the heart. Generally, arteries are oxygenated, and generally veins are deoxygenated, except in the lungs. Okay, so except for pulmonary, arteries are oxygenated, veins are deoxygenated, except for pulmonary. I'm going to show you that as we move forward. So again, one continuous loop. So this is our heart, okay, here. So I'm going to draw a little circle around the heart. It has a right side and a left side. And we haven't really studied heart anatomy yet. We will. But blood enters in the right side, okay, and then it'll go back out from the body. So body goes into the right side, and then it goes from the left side out to the body. Okay, that's how the blood works. So if you're having blood come in the vena cava, you may remember that from 201. That's the large vein that all the blood returns from the body to the heart. That blood will then come into the right side of the heart, and then it's going to be pumped from the right side of the heart out to the lungs. That's what's shaded in this area here. So the blood's going to go out to the lungs. You're going to give off your carbon dioxide, get your oxygen, and you're bring that blood back to the left side. Okay, now the left side is going to pump, and it's going to pump that blood to the body, okay, through something called the aorta. All right, so it's one continuous system. So you have two circuits. There's a systemic circulation, and that's the blood that's coming from the body to the heart and then back out to the body. All right, so that's one set of circulation. All right, so the pump is pumping blood from the body into the heart, and then from the heart out to the body. But between coming into the heart and going out to the body, it's got to go through the lungs, and that's the other set of circulation. That's what's called the pulmonary circulation. All right. So again, the blood's going to come from systemic circulation into the heart, but before it can go back out to the body, it's got to go to the lungs first, pick up oxygen, drop off CO2, come back to the heart, then it goes out to systemic circulation. So you have one pump pumping to two systems at the same time. Okay, so look at these colors. So people always want to think about the colors. In the systemic circulation, all the stuff coming back to the heart, that's all venous. So all the blue stuff, those are all veins. They're bringing deoxygenated blood from the body back to the heart. Once it's been out to the lungs and it's got oxygen, all the blood that's going out to the body, these are the arteries, and they're red. They have oxygen. Okay, so in the systemic circulation, the veins are blue, the arteries are red. But when they're traveling to the lungs, that's when it's different. Coming from the right side of the heart, you've got to send it out to the lungs. So this is an artery. It's leaving the heart. It's going away from the heart, but it's blue. It doesn't have oxygen yet. It's going to hit those capillaries, okay, in the lungs. It's going to pick up oxygen. It's going to return to the heart as red, coming into the heart. That means it's a vein, okay? Remember, how do you spell vein? V-E-I-N. So it's coming into the heart. That's bringing oxygenated red blood to the heart, which now goes out to the body. All right, so don't get too tied up and confused by those colors. All right, so this is what it would look like here. Here's blood coming into the left side of the heart, deoxygenated. It's then going to leave out with these big vessels here called pulmonary arteries, because they leave the heart. They're going to go out to the lungs. All these blue things are arteries. They're going to pick up the oxygen and return as these red veins to the left side of the body, and then be sent out into the left side of the body to be sent out into the rest of the body. You'll notice all throughout the systemic circulation there are capillary beds. You have capillaries in your toes, your fingers, your nose, your brain. Everywhere that you need to exchange blood, which is everywhere, all arteries turn into capillaries and then turn back into veins. Okay? It's just one continuous loop with some branches. So here's the aorta, and you've got these little branches that come off of it. All right. So our blood, again, it's in that loop. Most of it is in the vein. So at any one time, if you were to measure how much blood was in your whole system at once, most of it is going to be in the veins, about 60%. About 15% is in your systemic arteries and arterioles, in the arterial supply. 12% is in your lungs, in the pulmonary system, being oxygenated and having exchange going on. About 8% is in your heart, and about 5% is in the capillaries. There's a lot in the venous return, and this allows us to easily move blood as needed. Okay, so if you're shunting blood to the circulation, or if you're shunting blood to your core for temperature regulation, or if you need to increase your blood pressure, you kind of have a reserve. So we have a lot of blood in our venous system that serves kind of as a reserve to allow us to maintain homeostasis, and that'll become more clear as we move through these lectures. Now, all your vessels, if you think back to tissues, we talked about smooth muscle, cardiac muscle, and we had skeletal muscle. Well, the heart itself is made up of cardiac muscle. The vessels have something called smooth muscle. Okay, so it's a tubes. It's helping to keep the blood moving through those tubes. But these vessels have what are called layers or tunics. Okay, and so these are the three tunics that make up the vessels. The tunica intima, okay, that's lining the lumen. So it's going to be the endothelial layer lining the lumen, the inside of all the vessels. And it's made of the same stuff that's inside the heart, the endocardium. So the inside of the vessels, the inside of the heart is one smooth layer. If you think back to blood clotting, we want a smooth endothelium so we don't generate a thrombus. Remember that? All right. This tunica intima has a subendothelial layer of connective tissue, because remember, an endothelial layer needs to be connected by something, so you have a basement membrane. The middle layer is the tunica media, and that's where your smooth muscle is, okay? And this is where you've got fibers that allow you for vasoconstriction and vasodilation. So you've got the nerve fibers that come out that allow vessels to vasodilate, which is become bigger, or vasoconstrict, which is to become smaller. And we use these to change what's called vasomotor tone so that we can regulate blood pressure. So the more constricted it is, kind of the higher the pressure, the more relaxed it is, the lower the pressure. You have the tunica externa, also called the tunica adventitia, and this is a layer of collagen fibers, so you want it to be strong to hold all that together, and it acts as the anchor. It also contains nerve fibers and lymphatic vessels. So you have a lymphatic system that kind of runs parallel to your blood system. And these vessels, because they're organs, they need their own blood supply. So the blood supply that's feeding the vessels themselves is called the vasovasorum. Okay? So this is what this looks like. So this is the artery, and this is the vein. And you have your tunica interna, okay? Or, I'm sorry, tunica intima. We'll start from the inside, which is this innermost pink layer, the endothelial layer, okay? And then you've got the subendothelial layer and the elastic membrane. Obviously, I'm not going to point these out because you can use your textbook and the picture to see it. The tunica media, this is the smooth muscle layer, okay? And what I want you to notice, the muscle is much bigger on the arterial side than the venous side. So that tunica media with the smooth muscle is thicker, and so arteries are much thicker than veins. And so if you were to dissect something out, veins will collapse on you, and arteries are really thick. They're solid, so it's because of that thick layer of muscle, that tunica media. The tunica externa is that support, where that collagen is, and you can see that you've got little arteries and veins, or the vasovasorum. Those are the vessels feeding those arteries and veins. So arteries are going to have little offshoots that come off of them. They're going to have these like finger-like projections that are then going to make like a net, and then those nets are going to coalesce at the other end and form these little vessels here that go into the veins. So this would be the capillary bed. Now, between arteries and capillaries, we call this little thing an arteriole. Okay, so that's the little vessel that goes from the artery and into the capillary bed. What's coming out of the capillary bed into the vein is called a venule. Okay, so arteries become arterioles, become capillaries, become venules, become veins. Okay, and capillaries are really thin. They have a basement membrane and one layer of endothelial cells, so the oxygen and carbon dioxide can easily diffuse across in and out of the vessel and into either the body to give the body oxygen, or in the lungs to bring oxygen back into the blood. There are different types of arteries. They're not all the same. You have big ones and you have small ones. We have what are called the elastic arteries, the muscular arteries, and then the arterioles. And so the elastic arteries are really big, thick. They're large. They're our largest arteries, and they have a lot of elastin in them. That's why I call it elastic arteries. They're able to kind of really become large and then rebound to their original size. And that's what the aorta does. As the heart pumps the blood out of the heart into the aorta, and so when the heart contracts, it goes boom like that. When it contracts and pushes that blood forward, the blood will, when the heart relaxes, the blood's going to want to fall back. Well, there's a valve in the heart that closes, okay? And so that blood won't fall back into the heart, and so it'll continue to move through the aorta. But during that contraction, when it first pushes that bolus of blood into the aorta, it causes the aorta to kind of stretch, and then the aorta kind of relaxes again. And that blood, as it's bouncing back on that valve, that's what you feel as your pulse. And so the aorta can kind of expand and contract, expand and contract. But it's reacting to stretch. It's not actually vasoconstricting or vasodilating. Okay, so it's not doing that. It's just reacting to the big amount of blood being pushed through it. It's expanding like a balloon. So this is they're really great because they expand and recoil and help move the blood forward. And again, that's what you feel as your pulse, is that aorta expanding and contracting. You have muscular arteries, and this is going to be your next set of arteries. So remember, here's your heart. You have a big aorta, and then this is going to become little smaller arteries, and it's going to branch and 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 branch. And these are your muscular arteries, like your brachial artery in your arm, your femoral artery in your leg. And these are the arteries that actually go out to different parts of the body and the organs. Okay, they still have thick tunica media, but they do vasoconstrict. Okay, so there is some vasoconstriction going on in there. Now, kind of the last step before you get to the capillary bed, these are going to branch again into arterioles. They're the smallest capillaries, and they go directly to the capillary beds. And they will control how much blood goes in and out of capillary beds by vasodilating and vasoconstricting. So they're very vasoactive. So, for example, if you're hot, your skin flushes, that's the arterioles opening up and allowing a lot of blood to go to the capillaries so that you can dissipate heat. All right, so what's this look like? So here's my venous system, arterial system. Here's my heart. So blood is going in this direction, okay? So you have blood entering in from the vein into the heart. It's going to go out to the lungs and back, and then back out the arteries. So you have these large elastic arteries like the aorta, okay, that then divide into muscular arteries out to the individual organs that then become these arterioles that then coalesce as capillaries. The capillaries are divide out into capillaries, and the capillaries kind of come back together and become these venules, okay, and then venules collect together to form small veins, and these small veins connect to become large veins like the vena cava. And then parallel to all of that, you have your lymphatic system, okay? The lymphatic system is going to have the kind of terminal end of the lymphatic system near the capillary. So as fluid leaves the capillary, it'll be collected by the lymphatic system and carried back up to the heart through the vena cava, and it'll be dumped right back into the heart and back into circulation. So that's what this closed circuit looks like. Okay, so you have a heart, you have arteries, and you have veins. Let's see. When you get to the capillaries, they're really, really small. They're microscopic. There's just all they have is that tunica intima. It's just one cell thick, so they even have a small circumference. So just one red blood cell at a time can kind of go through that capillary. They have what are called pericytes, that not like a parasite you get if you're sick, but pericytes that help stabilize the wall and allow them to become more and less permeable, so that you can change how fluid enters and leaves the capillary bed. Again, they're very small. They're everywhere. You have capillaries throughout your body, except for in the cartilages, your epithelia, your cornea, and the lens of the eye. Okay, so everywhere else has capillaries. But these are close enough to a source of blood for them to get some, to get the benefits of blood. There's just no actual blood in those areas. So they're going to give direct access of oxygen and nutrients to every cell in the body. So what do? That's where exchange takes place. You're exchanging gases, you're exchanging nutrients, you're exchanging waste. Allows hormones to go in and out, into the blood, then go back out to the target organs. So that's what's going on in the capillaries. This is where things are moving. You have several different types. You have what are called continuous capillaries. They're not very permeable, but they're the most common. See those in skin and muscle. You have what are called fenestrated. They're more permeable. They have pores in them that allow for filtration and absorption, like in the small intestine and the kidney. And then you have things called sinusoid capillaries, and they're real permeable, like in the liver and the spleen. So remember when we needed those red blood cells to be able to be caught by the spleen? Coming through those sinusoid capillaries so that the old red blood cells can be taken out by the spleen, so they're real permeable. All right, so those capillary beds, remember, so blood is going to be coming this way through the artery, and some of it's going to continue going straight, and then some of it's going to turn and go into the capillary bed, okay? What you can do when you're determining how much blood's flowing through a capillary bed is you have these little pre-capillary sphincters that can open and close. So if they're open, then blood is going to go all through the capillaries, kind of equally through the capillaries, and then it's going to all collect on the other side and go back to the heart through the venous system, okay? If you're trying to shunt blood, so remember, just think that if you're really, really hot, all these sphincters are open, you're shunting blood, the capillaries are full, you're getting rid of heat. Let's imagine now you're cold, okay? And so now you don't want to get rid of heat, you want to shunt that blood to your internal organs. So you would close those sphincters, okay? So now all that blood's not going out into the capillary bed, okay? So your skin's going to start to turn that pale color. It's not flushed anymore. But you don't close off the gateway completely because you need the blood to be able to get to the other side. So there is a little anastomosis, little kind of gateway connection between the arterial and the venule that goes straight through. So it goes back to the vein. So you can change how much blood flows to an area by opening and closing these precapillary sphincters. Now what we want to talk about is if you're trying to have exchange occur in the capillary bed. If you're wanting things to leave the capillary or enter the capillary, we have to talk about how that actually occurs, okay? So I'm going to take a little break because I think this is a great place to stop. Come back in another video because I really hate for videos to get longer than about 20 minutes. So I'm going to stop here. We're going to come back and we're going to talk about how these forces allow things to come in and out of capillary beds, and I will see you in the next video. Hang tight.